Excellent. Well, good morning, good afternoon, and good night to all the Antelope Node operators who have joined. I don't keep track of how many calls we've had, so Daniel usually says this is the X hundredth call or something. I'm not sure. Daniel's not able to join today, so I'll be hosting. We've got a few things on the agenda, which I'll sort of ramble off right now, but then I want to, leave some open air for folks to bring up any items that they want to make sure are discussed. First thing is I want to talk about 5.0 and the status on release candidate 2 and the upcoming release candidate 3 and sort of the path towards stable there. And then the next thing is we have a couple of items to discuss that are issue reports in the LEAP repository. One related to peer-to-peer and another related to the amount of an option that configures the amount of CPU spent for block production, and basically we need to choose a new option name and sort of style for configuring that, and wanted to get some community feedback there. Before we dive into those topics, this is sort of the open air period here. We don't have to get into depth in anything just yet, but if anybody has topics they want to make sure are covered, call them out and I'll get them written on the agenda here to make sure we get to them. All right. So first thing, I see that Seth posted a question in chat about the invite. So it's still figuring out the sort of go forward plan on these meetings. So yes, this invite is indeed a one-off. There and doesn't have a recurring invitation at this point. So stay tuned. The main communication channel for where planning for how this meeting will happen going forward will happen in the Antelope Node Operators Telegram channel, and of course by email with an actual calendar invite as well. So look out for that in the future. All right, so let's talk 5.0 for a moment. Screen. All right, so whoops, screen here. Those are just issues. So last week we published, LEAP 5.0.0 RC2, which was actually the first release candidate, as I mentioned on the previous call. We've had a couple of folks sort of kicking the tires, so special thanks to Matthew Darwin and Michael over at EOSUSA and EOSNation. Or sorry, EOS, yes, that's it. For doing some of that proactive tire kicking for us. They've had a few reports of issues that are now sort of on the docket for fixes and changes for 5.0. I'm going to quickly review what some of those changes will be for the next release candidate. Before I go there, just wanted to sort of mention the catch-22 of these releases and put out the call for help here. The catch-22 is that folks generally don't want to upgrade until they see a stable tag, but on the other hand, we can't have full confidence that something's actually stable until we've had enough sort of as I put it, tire kicking happen. And so we do rely on community reports to make sure that some of the hardware configurations and things like that that aren't covered in our testing get put through its paces, so that we can get those things fixed if there's something that's going to be a blocker for you. Of course, we can do patch releases after stable, but those sorts of things obviously don't give people the feel goods or confidence when there's a lot of patches needed after stable. So this is just a call for help from the community. If you've got the bandwidth, please install 5.0 release candidate 2. You can just kind of do a local experiment, or you can run it on a test net, as it is not a consensus upgrade. So you can run it on a test net, and that way, if you run into any issues, you can give us a report. But even if everything runs smoothly, that's great feedback too. Let us know in the Antelope Node Operators Telegram channel group thing, if you've run RC2 and everything went smoothly for you. As far as some of the reports, we've got some items that are already done and will be in release candidate 2, some of which came in from community reports. Others were things that we had accepted as things we could fix after the initial release candidate. But there's nothing, what's the word I'm looking for, that fundamentally changes the nature of the release in any of these or in the open issues. In the open issues, the most notable things that we're working on are, we do have a report of a seg fault. I'm calling this one out because we have not been able to reproduce this yet. And so, again, additional tire kicking to see if other folks run into this would be appreciated. And that issue, if you're interested in the details to give it a look, is number 1764, reported by Matthew Darwin. And it's only happening in a specific mode, which is a new mode that is non-default, which is the database map mode equals mapped private. So, and only when you're starting from snapshot. But again, we've tried to reproduce this internally and have not been able to. So if folks do give RC2 a try, and you're able to give this one a look, that would be extra helpful. Other items are related to the like the build, reproducible builds that are new in 5.0. So producing signed binaries and CI/CD stuff, which will help people with doing local builds. But then there's some test fixes, which I think are mostly irrelevant for node operators. And the last one is one of the items that we're going to segue to, which is something that Michael at EOSUSA pointed out, which is that the sort of the behavior of the CPU effort percentage option has changed enough that it probably doesn't make sense to continue calling it CPU effort percentage. So I'm going to click over to that. So what we intend to do with this is remove the current option, CPU effort percent, which exists in 5.0 RC2. And in RC3, it would be removed and replaced with a new option. What we're considering is instead of using a percentage, using milliseconds. And for the details to talk this through and get feedback, I'm going to hand it over to Kevin Heifner. Kevin.
Yeah, thanks. If you want to scroll down
Yep.
to the first comment, there we go. So this was suggested, and I think it's a good suggestion. Conversation was happening on I think the jungle chat. Might be wrong there, but somewhere. And so yeah, instead of doing a percentage, which for me at least, and I think for everyone, the first thing you did with the percentage was pull out a calculator and percentage times 500 milliseconds. And it's like, okay, what's that mean in offset? And it's like, well, maybe we should just like define it in offset. I think that's probably the better way to do it. So instead of doing a percentage, what we're suggesting here is to change this in RC3, I believe, or which would be to get rid of the CPU effort percent, replace that option, or all four of those previous options that we had before, three of which have already been removed. But replace the CPU effort, the last block CPU effort, the last block offset, and the last block. I think I already said that. Anyway, those four settings: CPU effort, and then a block offset, and then the last block versions of those two. Replace all four of those with a new option: produce block offset MS, which will allow you to specify how many milliseconds for the entire round. So for 12 blocks, how many milliseconds do you want to leave at the end for latency of getting to the next block producer? And so in 4.0, before 5.0, the greatest that you could do there is really 500 milliseconds by putting like a last block offset, or offset of minus 500, or basically have a zero size 12th block would be the most you could do there. The new setting here, what that allows you to do is basically compress all of your 12 blocks into the first X number of seconds of your round, depending on this offset. And so you could set this offset to 2 seconds, for example, or 5 seconds for that matter. That'd be kind of crazy, but in which case it would compress all the 12 blocks within the remaining time frame, equally divided among that amount of time. So let's say you have 6 seconds, 12 blocks. If you set it to 1 second, then you'd take those 12 blocks and you'd produce them in 5 seconds. 5 seconds divided by 12 for each individual block. So that's what this new setting will do. If there's questions, comments.
So this doesn't cause any issue if we change basically the block time from being half a second on average to basically anything?
No, we already do that as well. Like the big change here really in 5.0 is the previous behavior was that you give an effort percentage. And so out of your 500 milliseconds, how much of that 500 milliseconds would you spend producing a block? And then you would effectively sleep, if you will, basically do nothing for the remaining amount of time of that block. What this does instead is say, well, instead of sleeping in between each block for the configured amount of time, instead move all that sleeping, if you will, all the idle time to the end of the round. So as soon as a first block is produced, let's say in your 400 milliseconds, if that's the way you have this configured, you just immediately start the next block. Now that does mean that you're going to be increasingly releasing blocks earlier than they were before. So before you could release a block up to, well, I guess technically up to 499 milliseconds early, depending on how long it took you to sign the block. But yeah, you could produce a block up to 500 milliseconds early. With this new setting, you can produce a block up to whatever, like 5 seconds early at kind of the extreme. But in general, we would expect someone to set the produce block offset to something like maybe 450 milliseconds or 500 milliseconds or maybe 600 milliseconds in kind of the extreme cases, maybe in optimal cases, simply 300 milliseconds or 200 milliseconds, depending on how good a peering you have with other BPs. And so yeah, it just changes when those blocks are produced. Now, from a consensus level, it's fine to produce blocks early within a given amount of time. I believe that a given amount of time is, I have to go check, but 7 seconds or so. And so we've got some leeway in terms of like when blocks can actually be released. And we've been releasing blocks early for for a long time, since 2.0, I think. Yeah, I think somewhere in the 2.x range is when we actually started releasing blocks early. Might have been as early as 1.8. Can't remember.
Thanks, Kevin.
Yep.
Yeah. I was asking because I thought we had like a way of mapping like a clock time to a block number, you know, based on half-second intervals. So I was wondering if that would impact that.
Yeah, and we still do that, actually. It's just that we'll produce a block for a given time slot, which are in 500 millisecond intervals. So if you look at the timestamp of the block, it's still going to be in those 500 millisecond intervals. It's just we'll produce, and we've been doing this for a while, we'll actually produce, say, a block for second, say 1.5. We'll actually produce it at 1.25 and release it early. So when you see, and that's why when you're watching log output from a Node.js, you see these negative latencies, and you might often be like, I'm sure that's like very confusing to people when they see, what in the world is a negative latency? What are we doing? Is Node.js doing like time travel type stuff? Like how is it possible to have a negative latency? Well, the latency there is measured in terms of the block production scheduled time, which is at the end of a block. So when the timestamp is for the end of the block. So when we get a block, we always expect those to be negative now because we're releasing blocks early. So we're producing a 1.5 block at 1.25. And so for the sole reason of getting it to the next block producer, actually before its time technically was supposed to be produced.
Okay.
And we do that because a while back, we figured this out, that there's issues with handoff between one block producer and the next. And so when a block producer wants to build its blocks, ideally you want to build on the 12th block of the previous block producer. That's ideally what you want to do. If you build on the 11th block of the previous block producer, or the 10th block, then those two blocks are going to be lost. Now, as Node.js running, you don't really know like whether you didn't receive the 11th or 12th block because maybe that node went down, maybe there's some network problem, or if it's just like if you waited another 10 milliseconds, it would actually come in. So what the software used to do back in, at least in 1.8 land, maybe in even early versions of 2.0, what would happen is a block would come in, and if a block producer had started producing, it would abort that block, evaluate the block that came in, and then try to build on it. Well, the problem with that approach is that it allowed somebody, really anybody, to send blocks and effectively keep a block producer its first block from having really any transactions if you timed it right. And you can do this for the first few blocks, or actually if you're clever enough, you can actually do it for the entire round, and you can effectively keep a producer, like the previous producer can keep the next producer from producing any blocks at all if they do the timing correctly. So what we did instead was we said, okay, we're going to introduce this new concept called drop late blocks. So what Node.js does now is that when it's a block producer's time to produce, on the time schedule that it's supposed to produce, it starts producing with whatever it knows up until that point. And if blocks start coming in after that, it simply drops them on the floor. It says, sorry, too late. You're not going to punish me because I got your blocks late. I'm going to start producing. And so again, you're going to have forks because of that, but the blame is shifted, if you will, to the previous producers. And so what block producers have done and have gotten really good at, I think, over time, is tweaking that last block so it has plenty of time to get to the next block producer. What this does is say, well, let's reevaluate how we're doing this to get better throughput. So now, instead of having those offsets between each block, we really move it to the very end, which is really the only kind of place you need it is at the end, because as a block producer, you have the previous block. You just produced it. You don't need to get it from anybody. You have it immediately available. And so you can build up this section of 12 blocks. You could almost think of it as one big block conceptually. You build it up and you release it. And this new setting will allow you to determine how much time at the end you need to get it to the next block producer, the last one. And so that gives you, like the default before this was 80%. So 80% of 12 seconds you use for building blocks. The new default in 5.RC2 was 90%. And even at 90%, that's 600 milliseconds for the last block. Michael indicated that he thought that was too much, like 300 should be plenty. So what we're indicating here is that we're going to say, well, instead of that, let's just do it as milliseconds, easier to understand. And we'll put that offset. I think we didn't mention what the default is. And so that's the question. Like maybe we should have a discussion of what would be the best default for this next produce block offset MS. I might suggest maybe 450 milliseconds. Maybe that's way too conservative. Maybe you guys will say 300 is plenty. Like we never see anything more than 300. I don't know. So would welcome feedback on what a good default for this produce block offset should be.
Conservative is probably better for the vanilla config. So it's going to definitely work no matter what, right? And work your way back from that, I'd say.
Would you say 450 is conservative enough there?
I don't know. Look, I haven't never looked at it like this before. It's getting all out of my head.
Well, we
Well,
did
think
whenever we
about
broke
like what
it
is
when
the
we were stress
maximum
testing.
value that anyone's ever set for last block CPU effort or
Well,
last block offset?
I do have
That-
a question.
Zero.
Go ahead.
Zero.
Well,
Okay, so that's 500 milliseconds. So
So
Yeah,
yeah, I mean the max we could ever
definitely
do.
works.
I mean that was the max we could ever do was the last block. Otherwise, everything else you could cut them all short. But I do have a question. And y'all may have tested it. I've tried to wrap my head around it. Haven't had enough coffee, but it's one issue we actually ran into before, and I'm curious how this new logic will handle it. Is we always struggle with blocks being late, right? I mean, it's the interwebs, right? It's really hard for me and Kangaroo Man down there to exchange blocks. And we unknowingly alphabetically stack ourselves together all the time. But that being said, hey, we should throw in to rearrange whatever that schedule fix is where you don't do it alphabetically. Can we throw that in as a GitHub issue? Anyway, that all being said,
that's a great idea. Like, I mean, that's already done on, is it Telos that already does that? Or
oh man, we redid it on Wax. We redid it on
yeah,
almost
Wax
all
as
of
well.
them because
I mean,
alphabetically
really,
is just
really should just
asinine.
somebody ought to throw that in a PR to the
Somebody remind me about that.
to the
Anyway,
system
what I
contract.
was talking about. So
that's not a Nodius change. That's just a system contract. So
yeah,
I
it's
mean,
like a one-liner. That's what.
Yeah,
That's,
somebody
and
should-
and whatever it is, the other one-liner that you can't dereg whenever you don't have 21. That's another little fix of stands
yeah.
that you should throw in there too. Anyway, write that down. But what I was saying was, we ran into this on, I think it was Telos, and it was accidental, but they got ahead and they drifted ahead so far, it really jacked up the round because they were like 3 or 4 seconds ahead. And so they really started getting into the middle of the previous producer's round. And it really started confusing the hell out of things because then you started getting these built blocks that it validated and shoved up the pipe too early. Now I'm curious the way it reevaluates the whole time frame and how does it work when I'm producing them all early and shipping them down the line, yet they're going to try to ship them in 2 or 3 seconds early, well into the boundary of micro. Well, it's still micro fork, but it ain't a one blocker. Have y'all tested it? And anyway, so that was something that popped into my head. But yeah,
no, that's a good question. There's no change here. I believe that's the case.
it's going to be a ripple effect, right? You're going to have just this onslaught of signed blocks from the first producer and then potentially signed blocks from the next producer coming in this dead time. Anyway, so that was what popped into my mind because we actually ran into that. It didn't drift backwards, it drifted forwards.
Yeah. Yeah,
Anyway, something to think about.
that has not changed. Like the semi-consensus, it's not even really consensus technically, but there's a limit of 7 seconds. I can remember if it's 5 or 7, but it's 7 seconds in the future is all that you're that a node will currently validate. But up until that,
Yeah, but it was
7
the system time. It didn't think it was early. The rest of the world knew it was early.
right,
So
and that's
it had
that's
that ripple effect.
Yes, that's the other thing as well. Yeah, if you got clock skew, then it
That's
can
exactly
cause,
what it was the clock skew. I'm curious how,
can
and like I
cause-
said, it did not handle that. I mean, it did. It micro fork, it handled it. It did not lose consensus, but
right.
it
Yeah,
it
no,
took a really good effect, and it was hard to see because it was just a bunch of little micro forks.
you're right. You'll get a ton of forks in that situation. There's not really, yeah, there's should be no change in that regard, and there's really not much. I don't know. Say there's nothing we can do about that. I'm not sure, but at least I don't think there's much we can do about that. You know, if a producer thinks that it's clock, you know, according to its clock, it's skewed, thinks that it's time for it to produce, it'll start producing. And depending upon whether it's actually in its window of production. Now, if it's skewed completely out of its window of production, nobody will validate those blocks. It'll say, sorry, you're not scheduled to produce now. I don't know what you're doing. But if it somehow overlaps, like it's not skewed enough, then yeah, some of those are going to be seen as valid and some are going to be seen as invalid. And it's just going to be, you know, how it flows. You're going to get all sorts of micro forking happening until that producer's done. And the next guy that's got a good clock gets in here and kind of cleans everything up. And you know, until you get around to him again, and then all hell breaks out again. Right. So, yeah, it's kind of the way that's going to work.
I'm curious. I mean, I can go and do it. People are probably gonna do it on accident, but I'm talking seconds. It's not this half a second, one block, whatever. It was several seconds, and I'm curious now if you're gonna fire all of these out.
Yeah,
Maybe.
well, try it on jungle. Let's see, right? Change your clock.
Yeah.
And see what happens.
Yeah, we're gonna have to try.
I mean,
How did
it
it perform
won't.
in
You're
your?
not gonna brick the chain. Like, pretty confident
Yeah.
that will not happen. But you might cause all sorts of havoc with forks for sure.
Hyperion hates us.
Hey, how did it perform in your testing? You seem very excited about it, Kevin, and I'm excited because you're excited. How did it perform in your lab testing?
Yeah,
It worked.
it seems very, yeah, actually very well. Like we could see the blocks being produced early, and it gives it plenty of time to make it to the next block, which gives it plenty of time to start building upon those blocks. And so, yeah, on a distributed environment, it seemed to be very, very nice.
Well, sounds like we're going to be doing it on Jungle first, hey, Michael. Pat's already on it. Let's do it.
Well, I don't know. I'm concerned because, I mean, you know my ulterior motive behind that, and I don't want to brick. I mean, what happens if you truly smash the snot out of all those blocks and downstream them? So,
well, I mean, even more thoughts, or I don't know. I don't want to use the word concerning. But the other thing to think about in 5.0 is the fact that we have the EOS VM OC optimized compiler factored in by default for EOSIO.star accounts. And so, yeah, this change right here is targeting more throughput, right? I mean, we're talking of going from, you know, 80% of 12 seconds to maybe as high as 95% of 12 seconds for a block producer producing or putting transactions in blocks, right? So that's an improvement. That's an increase. The EOS VMOC packs more transactions into those blocks. So yeah, where are you going to feel the pressure? Well, the pressure is going to be on the history solutions, right? That are trying to keep up. Yeah, I mean, certainly feedback there is going to be important. Now, again, you have the knobs if things start getting like you're finding it's too much down pressure and you need to relieve some of that pressure. You've got the knobs to dial. You can dial this one back, right? You can decrease the max block CPU on chain even. Actually, I think there's room there to grow. Like I have a feeling we can actually increase that value, not decrease
That's
it.
the plan.
Yeah, so I think, I mean, we've got plenty of capacity, I believe, certainly on mainnet, but even on wax, like I Nodius, there's a ton of performance improvements from the 1.8 days to where we are today. Like it's a much more tuned engine. And so really it should be able to handle the load. Now, whether Hyperion and those other things can handle it or not, I guess would be the question. Although I would suspect they can, because a lot of those I believe are multi-threaded and you know, we have faster disks these days and et cetera, et cetera. So we're not anticipating that this is going to be a problem, but obviously if it does, we can dial back some of these numbers to alleviate some of the load. But I don't think high capacity is an issue at the moment. Some people from Wax might disagree with that, but we'll see.
One last question about that new setting. So suppose you would set your produce block offset millisecond to a value that's too low. Would basically the danger of doing that would mean that your last block that you produce might be forked out
it would be, yes, that's exactly what happens.
That's how it is today.
Yeah, and potentially the last 2 blocks or 3, you know, depending on how slow it is to get to the next block producer. Then yeah, that's what happens. So the next block producer on its scheduled time will start producing, and if the block comes in after that, it simply drops it. It doesn't evaluate it, it doesn't look at it, it doesn't care anything about it. It simply drops it on the floor, and then it starts producing. Now, what that's going to mean is that producer is going to have the longest chain, right? Because everyone else got that 12th block and potentially validated and actually built a chain on it, because why not? And then they're going to start getting blocks from the block producer that produced over it, if you will, quote unquote, over it. And so for a block or two there, they're going to be equal. Well, for 1 block, they're going to be equal. And then the producer is going to produce the second block of its round, and that's going to be the longest chain at that point. Once everyone gets that, they're going to say, oh, you know what? That's the longest chain. Everybody will switch to that one. And then everyone will fork out that 12th block of the last producer. But there is a moment of time, depending on network latencies, where people, well, and really almost everyone's going to get that 12th block and build on it first and then fork it out, because it's going to take a while for that first block to be produced, right? So unless somebody, you know, there is situations where if you're better peered and you're lower peered, then yeah. But in general, what's going to happen is everybody's going to build on that 12th block. They're going to get the first block, they'll add it to their fork database. They'll get the second block and they'll go, oh, need to switch to it, fork out the 12th block, apply the first and second block, and go from there.
Cool. Thanks a lot, Kevin.
Yep.
All right. Just to bring this one to a close, it sounds like there's general agreement with this naming, and then but what I didn't quite pick up on is whether we had agreement on an appropriate default.
I would suggest 450. Does that seem like a?
Yeah.
Yeah,
As a
I mean,
default.
Yeah. There's no default, and some people don't even like giving default recommended settings. But I do think that the default that a lot of people probably have was 300 milliseconds. That was when y'all first introduced it. It may have been 1.8, but that was kind of a sweet spot, that 200 milliseconds and out the door, right? So that was the idea, but that completely changed when y'all repurposed it. So that's why I'm excited. Yeah, deprecate it, and 450 at least gives you time to get a transaction, like an on block at the right time. I'm curious, the change to what I call the mempool. What is it? Unapplied transaction queue. I forget what you call it, but because you're going to kick these blocks out early, which means there's no ability to process any transactions that come in at the actual block time. So they're going to roll to the next block. You kick it out 1-2 seconds early, that's 4 blocks, which are going to get kicked out as empty. It's fine, easy to build on that, but that I'm curious, you put it under pressure or even light pressure, we've seen, you know, I don't think it's going to be too bad. We broke the hell out of that queue, so it'll handle a lot. But we're now going to kind of intentionally be trying to cut it short. That's why I said below 500 is I think a bad idea for a default, because you're forcing the 12th block to always be empty. So at least 450, 300's even full. You can still get full amount of time. If you can get that transaction in that 200 milliseconds of that block schedule time, it would technically still be able to get to that block. That's, I say, because that for a private chain, that's exactly what you do. But you can always override it with your own configs.
Right. So I mean, you know,
Kevin, in this case, the last block would not be empty, right? You would just have built it in advance, right? But you would not take into account the transactions that come into that last 450 milliseconds. But
right.
all the blocks would be correctly built, you know, on probably the same.
As long as it's less than 500 was the original request.
Yeah, and I agree. Like I think setting it higher than 500, which is fine if you know you've got like really bad latency between you and your next guy, and you just have to do that. Well, fine.
Yeah, you got the knob to turn it to whatever. Again, 5 seconds.
Right, but in general, I think it's better optics, if nothing else, than it ought to be less than 500 as a default for sure.
Yeah, percentage.
You know, and I think probably
idea.
like you're saying, like you guys have really good peering on a lot of your networks, and so you know 300s maybe plenty, and you guys can tweak that. But yeah, but again, you know, the good thing here is you're getting a pretty good increase in throughput with, as you say, an issue with latency in the last 500 milliseconds of a 12-second round. But in general, you have that today because people have to set their last block time very small. And so you already have those latencies in that last time slot anyway, because people are adjusting it. So I'm not sure that in reality, there will be much difference in latency near the boundary of that 12 seconds, or I'm sorry, I keep saying 12 seconds, 6 seconds boundary anyway.
I'm excited. Well done. I know that was years ago that we started kind of talking about that idea. So
yeah, I think it's been a number of years since we talked about actually doing this. We did it. So yeah, pretty cool.
So this, along with the overclocking of the EOSIO specific contracts.
Yes, yeah, we apply it to EOSIO.star account, so that's going to include token, which is cool, but EOS EVM, which is really key, right? That gives that EOS EVM execution even more a processing power there. But you know, those two are the key ones. But anything in the EOSIO.star account, so multi-sig, wrap, do we still use wrap? I don't know. But yeah, anything on the EOSIO.star accounts.
So that's going to be lots more performance then, eh?
Yeah. EOS EVM, of course, is a big one, but token, you know, token, at least in various parts of the history of the chain, have been the number one contract.
Popular one.
So you get, even that will get, you know, performance boost. Now I don't know how much of significance it'll make an EOS out of the token, but yeah.
When you say performance boost, if you already had OC on, is there a difference between having it been forced in the first place?
No, but the
be
difference there, right, exactly, there's not. And so like for your history node, which you should already have OC turned on, there will be no difference there in terms of performance. It's just on the BP, it'll be able to execute those, and on API nodes, and you know, on all nodes getting up there. Like today, you don't run OC on API nodes because you don't want to give that false sense of it working. So this will apply on API nodes, it'll apply on BP nodes, it'll apply on relay nodes. So basically everywhere by default, EOSIO.star accounts gets that extra performance boost. And that'll include Telos's EOS EVM as well, because they have it on a EOSIO.star account. Is my
Seth
understanding.
asked, and I think the
Yeah.
answer is about the BPs having it off. I think most BPs, the instructions were not to turn it on because it was always
Correct.
off
Yeah,
by default.
yeah.
Yep.
So if you
Yeah.
have it off, it would stay off, but the default is auto now.
Yes,
So-
right. And so on your BP, we'll suggest that you actually move to the auto as opposed to
Right.
off. You can leave it at off
Okay.
if you like, obviously, but the
Yeah.
auto should be fine.
Or comment it out and just don't specify it and it'll
Exactly.
default to auto. That's,
Exactly. So on a BP, that's what we're suggesting for 5.0 is when people upgrade to it, to go with the auto and get that performance boost. Because the issue with running OC on every account is that, you know, that opens up for, you know, these, if you will, compiler bombs, whatever you want to call it, where, you know, account runs just orders of magnitude faster on OC than non-OC. Now that should not be the case on EOSIO.star accounts, because those are all controlled privilege contracts. They're not all privileged, but they're all controlled contracts that, you know, are evaluated and set by you guys. And so, you know, you're not attacking yourselves. So.
And Seth also had a question about the max transaction time 1, read only, read window time.
Yeah, there is no max transaction time 1, right? I mean, that's just a typo because my node rejected it when I renamed it.
Yeah, does it say that in the docs or something?
Yeah, in the setup instructions, I posted that in the channel, but it says
Oh.
to get rid of the old one and make it max transaction 1, which doesn't exist. But
Yeah, sorry, that's just a typo.
it's all right. But I mean, I think to answer his question, I think you can do whatever read transaction time window, read window you want on your own nodes. These were the defaults you guys had suggested just for public node operators in general.
Yeah, I
But
think
nothing
Let's fix
changes.
this on the fly then. So this is supposed to just not say remove, it should say set, like that.
yeah.
Give or take. You can remove it to put the right one back.
Yeah.
Oh, that's funny. Yeah, I don't know how that got missed. But yeah.
I think it was probably telephone. There was a typo somewhere in the chain and I propagated it. That's probably what happened.
Got it.
Well,
Got it.
I
Yeah.
tried to do it word for word and it didn't work. So
Oh, well, actually, I thought we were suggesting people set max transaction time to 499. Like anything above consensus.
on Telos, they've done that because their EVM transactions were getting big, I think is the fundamental reason. So, but that setting y'all came up with a while ago.
Yeah, so
before
that's
Telos.
Yeah, the same reason we're talking about doing it for EOS mainnet as well, is the EVM transactions, you know, can be hefty. And so let's give them more breathing room to run in.
It's the same concept. Telos just opened it a little farther, right? Which we can still do.
Oh, right. And the other thing that's kind of related here, we saw this with max inline action size, or whatever that other thing that we recently put in here as well for getting rid of that. In that a lot of these subjective changes we now feel are better controlled on chain. For example, max transaction time. Well, there's an on-chain setting that's been there since launch, and it's set to 150. But you know, you guys, the node operators or everyone, the default for a given node is 30 milliseconds. Well, why have an on-chain setting that's so much larger than the default? And so the idea here is to kind of move to more of controlling this by the on-chain setting.
Yeah. So we definitely do have an error here, because we specifically could call out removing this so that enforcement is driven by the transaction wall clock deadline that's on chain, the objective on chain limit. So I'm wondering if actually the remove was the correct note that we intended.
Well, by remove we mean comment out in this case.
Yeah.
Which is not, you know, well, I guess that for a node operator, yeah, remove and comment out's the same thing. But for developers, like, we didn't remove the option. We just changed its default.
the default's fine. The recommended settings may be that for public general nodes. And then yes, Telos can go to 499, you know, I mean, whatever a
Anything
chain
above the-
decides based off of their contracts.
Yeah, any value above the on-chain consensus value, which is currently 150, I believe, on all chains. Like, I don't think anybody's changed the on-chain consensus value on any chain that I'm aware of. And so anything above 150 means that what's enforced is the on-chain consensus value. So it doesn't matter if it's 151 or 499, as long as it's larger than whatever's on chain. The idea of setting it to 499 or whatever is the fact that then if you guys determine that like 150 isn't enough, like you'd like to go to 200, you can simply do it as a multi-sig and everybody gets it, right? You don't have to then say, hey, everybody, please upgrade, you know, please change your setting from 151 to 200, right? The idea is like comment it out or just set it to 499 or something. And then now the BPs can control it network wide by a consensus setting. And maybe even like if you needed to change it to 100 for some reason, you could go either way, right? And then it applies it across everyone as opposed to trying to get everyone coordinated to say, hey, can everybody please change their configuration setting?
Got it.
So should we set the default value to be 499? So
I think we first set it to 475, but yeah, whatever, somewhere around 500, a little less than 500.
How about that? So comment out or remove max transaction time or set to a value above the on-chain limit, e.g.
Yeah.
More than 150 milliseconds on EOS, right?
So if you set it below the
Mhm.
on-chain limit,
Mhm.
then your node could actually enforce it.
That's correct. So yeah, it hasn't changed. Like its capabilities and functionality is exactly the same as it was before. In that, you know, currently the default's 30 milliseconds, which effectively means the biggest transaction you can get in, unless you happen to have, you know, unless a BP actually has their API node with a larger setting and a relay node with a larger setting and their BP with a larger setting, you know, and that allows you to path in. Then without that, effectively the limit is 30 milliseconds today because that's the default that everyone runs. So yeah, but yeah, even after this change, even with 5.0, if you want to set it back to 30 or leave the 30, like if you actually have it and you config that of max transaction time 30, it'll still enforce the 30.
Yeah.
I'd say a lot of people probably have it because when y'all defaulted that thing, it used to be higher. And I think, I don't know, maybe that was the response time, but I remember the reason we had them set is because you would find, especially on like test nets and potatoes, that it was so much different that it needed to have longer time because once somebody else did the work, it was different.
So Seth is also asking about the best setting for read-only read window time. So my understanding, Kevin will fill this in, is you don't want to set that too high because you don't want to consume all of your time for like read transactions, right?
Well, in theory, yes. In practice, it doesn't matter a whole lot. Again, this is why it's a knob. Like it all depends on what you're trying to achieve. So let's say that you're a BP and you're doing really good configuration. Well, what we might suggest you do is you dedicate one Nodius to a read-only capability, or maybe multiple Nodiuses to read-only capabilities, and other Nodiuses to push transaction and send transaction and send transaction to. And so you route your HTTP request that way. If you do that, then the nodes that are not handling the push transaction stuff, you could set read-only window time to whatever, 500 milliseconds, 300 minutes. It doesn't matter because it doesn't matter what that setting is. If a block comes into the node, it gets out of the read window, evaluates the block, applies it, and then we'll go back into the read window. So you can set it at that for that type of node. You can set it as high as you want. Now there's another setting though that is actually as important, if not more important, which is the read-only write window time. And so the write window time on that read-only, you would want to set really small, maybe like tiny, like, well, you can't set it way too tiny, but something like, 20 milliseconds or 30 milliseconds. Because again, when a block comes in, it's going to apply the block no matter what. And if it takes 3 minutes to apply the block, it's going to apply the block. It will apply the block no matter what that setting is. And then it has the potential to stay in that write window for whatever the configured value is. But if you have a node that's dedicated to read-only transactions, you really don't need to be in the write window at all, because you're not going to have anything to write except blocks, and blocks happen no matter what your setting is. And so on a node that you've dedicated to read-only stuff, you'd want to set the write window very small. Now, the flip side of that, if you got a node dedicated to send transaction and push transaction, on that node, actually set your read-only thread pool to 0, and then it won't matter what the setting is. It'll never do a read window. Now, if you have a node that, let's say you're a poor BP, and you only have one API node to everybody, and you want it to handle both, well, then I don't know. Set it according to what you see. Like, I don't know if you get more push transactions than get info and get table rows. I don't know which would be more, but then you'd want to set it to have the window sizes that are appropriate for, like, how much you want to allocate for get table row and get block, and how much time you want to allocate to push transactions and transaction. Does that make sense?
Indeed. All right, we're almost at time, and we haven't covered this yet, which is a PR that for labeling of peer-to-peer, peers. I don't know if we have time to go.
We might want to push this to next time. I don't think there's any hurry on this. It can set another week for sure, and we don't have Matthew Darwin, which I think might be person that might have the most input on this particular item.
Sounds good. All right, so I'll close out with this, just a sort of restatement that yes, we have RC2 available. So go pull that down, kick the tires, put it on Jungle. Let us know if everything works smoothly for you, or give us some issue reports, and that helps us be more confident when we pull the trigger on promoting to stable, and avoid patch releases that we maybe could have caught in advance. So yes, we're looking forward to your feedback. And with that,
Great.
I'll close out the call. Thanks, everyone.
Thanks, everyone. Catch you later.